of the page table is 4 bytes. So you can see that because here the page frame is 1024 bytes, so the page size is the page size is 10 power of 2, okay? And because the logical space is 32 bits, okay? So the logical space is 32 bits. So we can divide the logical address into 2 parts. The lower 10 bits is the page offset, okay? It is 10 bits, okay? And the higher 20 bits is the page, and the higher 20 bits is the page, higher 20 bytes is the logical page number. And because so the page number is higher 20 bits, and we can see that because each entry of page table is 4 bytes, that means in the page table, each item, the width for each item is 4 bytes, and the page size is 1024 bytes. So we use 1024 bytes divided by 4, we get 256. That means in one frame there are 256 items of the page table. So it equals to 8 power of 2. So we have to divide the page number into from right to left. We have 2 right to left. We have to divide the logical page number into, maybe let me say, into 3 parts, okay? 3 parts. So this is P1, okay? For the P3 it is 8 bits, and P2 it is also 8 bits, and P1, as for P1, let me change the pointer. As for P1, okay, it's very hard. As for P1, because here altogether it is 16 bits, and for this part it is 20 bits, so we use 20 minus 16, we get 4. So for P1 it is 4 bits, okay? So there are 3 levels for this example, okay? How many levels in the page table? 3 levels, the page table, okay? And one address mapping, how many parts the logical address is broken into? We say it is 4 parts, the 32 logical pairs, 32 logical address is broken into 4 parts. Okay, the first part is 4 bits, and the second part is 8 bits, and the third part is also 8 bits, and the lower 10 bits is the offset within the page. So this is the answer for this exercise. Okay. Also, that I find that exercise this exercise. The memory management scheme is paging. One job has 4 pages. They are in this page frame. Suppose that one page is 1024 bytes. The space of main memory is 10 kilobytes. Please write out the page table of the job. So you can see the page table for the job. Okay. So let's look at So okay, let's look at, first we write out page number 83468. So we draw it, the page table. It is this one, 3, 4, 6 and 8. So that means logical page 0 is loaded into frame page 3, and the logical page 1 is loaded into frame page 4. This is the page table. And also translate the logical address 2100 and 3100 of this job into physical address. So because the page size is here, and we use this, so we use this one, divide the page size, we get the quotient, the integer part of the quotient is 2, and we use this divide 100, and we got the remainder of the quotient is it is 52. So we use this. This is page number, and this is the page offset. We use which formula? Of course, this formula. Okay. So the integer part is the page number, and the remainder is the page offset. We use the page number to search this page table. We get 6. So that means logical page 2 is loaded into frame page 6, and the starting address for frame 6 is this one, and we plus the page offset, we get is this one. So, and as for this one, it's the same. Okay, we use this is the logical choice. Divide the page size, we get the quotient, we get the integer part of the quotient. This is the page number, and we use this one, divide the page size, and we got the remainder of the quotient. We get this one. We get 28. So this is the page offside. We use this page number, search for this page table, we get 8. Okay, because you must remember the first item is index number is 0. So this is 0, 1, 2, 3. Okay, and we get 8. That means the logical page 3 is loaded into physical frame 8. Okay, then we use the 8 times the page size. We get the starting address for the frame page 8, and we plus. And we plus. Okay.